Hey dears, welcome to the second video, the series of DSA data structures and algorithm. Today we are going to discuss about the algorithms in detail, algorithm analysis, how we are going to analyze that all different types of algorithms. First, let's define what is algorithm, why we have to learn the algorithm. So let's when we talk about the algorithm is sequential steps, or we can say the sequential instructional statements for solving the specific tasks. Okay, so if you are going to solve any problems, you have to find out the different actions, different statements, different instructions, what you are going to after which that is the algorithm. So we can say it is the well-defined sequence of instructions in sequential order. Also we can say that takes some input to produce and provides the outputs to achieve our desired outcomes. So it is used to solve the problem, we should say, efficiently and effectively, providing a systematic approach to finding the solutions. Also, we can see it is the building block of computer programs that are used extensively in fields such as data analysis, machine learning, or even codings or sortings and optimizations of the program. So algorithms can be represented by using the various notices, such as we can say the pseudocodes, flowcharts, and programming language. So also we can say this algorithms is required before the programming or before the learning, because it's developed the logic about the problems. It helps to understand the problems. It helps to develop the different logics, how you're going to solve that particular problems. Not only that, it helps to analyze that our activities, if you'll go which way or which activities you are going to execute after which, and what is the effects, means in different, we are going to learn about how we are going to analyze our that all activities. That is the algorithms. So like in the based on that time complexity and the space complexity. Okay, so we will find the best alternative algorithm as well as, so that helps too. So let's find the key characteristics of the algorithms. What should be there? So well-defined inputs, outputs. There must be defined input output. So what you are going to define, so what you are going to input to the computer and what will be the output, that should be clear. Precise instructions, so what you are going to instruction after that, like if you are going to find the solution or additions of that two input, then obviously you have to give some two in numbers, and you can find the additions. So that all should be instructions. And finite steps means there must be finite steps. You cannot include as is much as all the time change. No, if you write once, it must be fixed. Okay, and deterministics, it must be deterministic, means your obtained output must be clearly, like after the what you are going to find the outputs after, so that must be clear about that all. So in like deterministic means your output, what you want, what you wish, your desired output should be clear. Efficiency means able to solve the problems in efficient manner, or means effectively how you're going to, in the case of like less time, by using the less time while running, and then less space that used while running, it requires less memory. That is the efficiency. So based on efficiency and like effective running, we are going to analyze. So let's give some example of algorithm, how it's going to develop our logic, that I would like to make you feel, so that you can focus on this. So as simple, I'm going to write here, maybe you know, you have already gone through that any other programming anyways, but make sure that while running this DSA, before running the DSA, it's a requirement. As a requirement also, we can say that you must be able to code in any particular language, either C, C++, Java. So, but you must be with good command on based on like how to write the different functions, pointers, or maybe you can like recursive functions or loops. You must know about that. So okay, so here algorithm to find the highest numbers among three different numbers. It's a very simple and short. I'm going to write here. So first, what we have to do first, let's analyze this problem. So here three numbers, so our input will be the three numbers. We need that three numbers. Without getting that three numbers, how you will analyze the highest, which one is the highest? Okay, first you have to take that three different numbers, and that three different numbers should be as a variable. That can be any. Okay, so anyone can be the highest. So we have to make one logic. So let's first here read the three numbers. We have to read that three numbers and check if A is the greatest, then B. Okay, so see here, B and C. If A is the greater than B and C, obviously maybe while checking, okay, so you can find if it is true, so display A is the highest number. If it is false, go to the next steps. So if A is not greater than B and C, then what to do? So we have to check the B as the same. So B is the greater than A and C. If we'll say it's true, then B is the highest number. If not, then obviously C is the highest number. We don't need to go again with the C to compare with this R, because if not B, if not C, then obviously if not B is the greater, if not A is the greater, then obviously C is the greater. So in this way we can do, or you can write in another manner also. So I'm going to show you here. Start is a kinds of flowcharts. We are going to represent these algorithms in the flowcharts. So you start and read that ABC three numbers, and here are the comparisons. If A is greater than B and A is greater than C, then in this case, if it is true, then we can say display A is the highest number or the greatest number. Okay, so if no, okay, so if no, then of course we have to think about another condition. So let's compare the B with A and C. So if we can say the B is the greater than if I have not given here, it's my statement is wrong. So you can say the B is greater than A and B is greater than C. You can understand, please try to understand this. If yes, then of course B is the highest number. If not, no, then of course we can say this. So these are the different symbols. If you have some confusion about this flow charts, what is the flow chart, how we are going to organize this different shape, that simply we can use that different shape? No, we can't, because its flow chart has some basic rules and some well-defined shapes. So please, if you have confusion, you can I have already explain about these different flow charts and algorithms. You can go through that my previous video, that will be fine in the list. I will track here in detail. So display sees the highest number. In this way we can find with this different. So see here, you can find in shortlets. I would like to go with this start and end. You can find here start and end with like a oval shape, and then see here it's input output box, that is also known as the parallel box. So for display and to take input is the different. So these are dynamic, and here are the flow line. This is the arrow, these are the flow line. So you must use this flow line, that is essentials. And let's find another way. So you can write the algorithms in this way. So read the three numbers, and if check if A is greater than B. Suppose if A is greater than B, then you can say that A is the greater, then and check if it is true, then check again with the C. If C also is greater, then of course A is the highest number. You can do like this also. So you can go through this. It's a way to analyze. So but I'm not going to teach you here how to write the algorithms right now. So in another step we will go. So please, if you don't have the basic concept about this algorithm and flowchart, please go through my previous video or give me in comment so that I can help you in further in next video. So let's talk about the analysis. What is analysis? For what purpose we are going to analyze this algorithm? So I just show you the algorithms, and some algorithms we are going to analyze. So analysis means it is the process and understanding the efficiency and performance of the algorithms. What is the efficiency of algorithms? How we are going to perform, what is the behaviors or characteristics of that algorithms in the case of nth input, larger numbers of data. Okay, with the larger numbers of data means n means large numbers of data. So it involves in studying and then how an algorithm performs in terms of complexity. Means there are different types of complexity. In term of complexity, I told you it's like time complexity and space complexity. Time complexity means how long it takes to run, and space complexity, how much memory does it requires to execute. So in this base we are going to analyze the um, algorithms. So the purpose of algorithm analysis is to assess the efficiency of the different algorithms for solving the same problems and determine how algorithms is executing and which is the best and suitable for the particular task. Maybe our structures is different, like some our data must be in the stack, must be in the queue, must be in a list or linked list or doubly and singly linked list or maybe tree or graphics. So this according to our data structures, how they are going to perform in the case of complexity like time and space. So we have to analyze that all. Okay, so let's mathematically we will try to analyze that how this nth input base, how they are taking the time. So we will analyze that. Okay, so it is the essential process of designing and implementing the efficient algorithms or the best algorithms to select, okay, various applications ranging from the simple computational problems to the complex tasks in the areas such as data processing, optimizations, and artificial intelligence. So everywhere these are required. So let's talk about the efficiency and complexity. In the base and efficiency and complexity, we have two different types of analysis. Also we can say like computational and asymptotic. So let's understand first computational, then we'll discuss about the asymptotic. Asymptotic is more important and complex, so but it's don't be like hectic. So there we will discuss in simple way about this asymptotic. So let's first understand about the computational. Computational complexity and asymptotic complexity are the two related concepts of the computer science that help analyze and classify the efficiency of algorithms, so that we can understand which are the best algorithms for which data structures. So it's vary according to data structures, okay, according to the numbers of data, as well as suppose even you can say like I'm going to give one example in real life. Suppose here, so one vehicle is like, let's talk cycle is also vehicle, and even motorcycle is also vehicle, car is also vehicle, bus is also vehicle. Suppose we are Kathmandu and our hometown is Chittagong. It's not so far, it's about 200 kilometer. Okay, so let's think, or 300 kilometer, not more than that, I think 200 kilometer. So let's we have to reach there. So which one is the best way to go there? Yeah, we understand if we have a short distance, like it's a 1 kilometer or maybe for 200 meters. Okay, so that the best is the cycle, or by walking. It's a walking distance, you can go walk. And so it does not take time. But if you'll use like any other vehicle like bus, then call bus, go there, and it takes time. Okay, suppose if according to that time, according to that means condition situations, we have to choose the best alternative. That I mean, okay, so please let's understand. So computational complexity measures the amount of resources required by the algorithms to solve the specific problems. These resources can be like time, memory, or network bandwidth, or maybe any other metric that relates to the performance of algorithm. The primary focus usually on the time complexity and space complexity we will talk. Okay, so let's talk about the time complexity first. If the time complexity measures the amount of time it requires and algorithms to run, and as grows to inputs as size increase, and also provides the operations or steps required to solve the problems. Time complexity is often expressed using the big O notation. Big O notation, this about the notation we'll discuss in next another video in detail. Suppose big O notations means like in worst case the long required times. Okay, so big is also called worst case. In the highest case, as you increase the numbers of data, or means nth value, nth input, it takes more time. So that is big O notation, which gives an upper bound also it is called, and growth rate of the algorithms running time. Example algorithms with the time complexity of big O here also written, okay, big O n squares, or it is also called quadrical. Okay, quadrical means running time goes quadrical with the input size. So we will analyze this all later about the big O, big omega, or big theta, that we will discuss in next another video about it, this all in detail. So now let's talk about the space complexity. Space complexity measures the amount of memory or storage space required by the algorithms while running or to solve the problems. It estimates the maximum amount of memory used by the algorithms as the functions of input size. As if you increase the input size, how does it's going to required require the main memory. So it's also like big O notations also we can use, or we will try to find the big omega. Okay, so that means the best one, the less memory users we will find. So for the instance, and algorithms with the space complexity of big O n means as you increase the input size, it's linearly how does it requires the space. So another we have a random access complexity measures that amount of the time it takes an algorithms to access random elements of the data structures. So also we can say the communication complexity. So this about the network bandwidth and other else. So measures the amount of communication requires between the two processors to solve the problems. So and now we are going to discuss about the asymptotic complexity, but I would like to go before this complexity in next video, so that we will discuss about this all in detail about the asymptotic. What is asymptotic? Because in asymptotic we have to go with the calculations, like later I'm going to show you in short about this. So because data as efficiency of data structures, if you want to go with this with example, if you go that that will deal with all different complexity, like time complexity as well as the space complexity with this array or linked list, or maybe stack and queue. So this all are different, so we'll discuss about this in next video. So I think I must conclude till now here. So we'll discuss about this all asymptotic in next video. So please keep in touch like, subscribe, and share this video if you really like. So we will discuss about this all. So thank you for this right now.